Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Voice over IP, often shortened to Voice IP, is the collection of technologies that allows voice communication to be carried over IP networks instead of traditional circuit-switched phone lines. This shift from analog to digital voice transport represents one of the most important transitions in telecommunications. By moving voice traffic to the same infrastructure used for data, organizations reduce the cost of managing separate systems and gain flexibility in how calls are routed, managed, and integrated with other services. For the Network Plus exam, understanding how VoIP functions and how protocols like SIP and RTP operate is crucial for working with modern communication systems and answering application layer protocol questions. PS systems rely on two distinct categories of protocols to function. One set of protocols handles the signaling, which includes initiating, managing, and ending a call. The other set manages the actual media stream, meaning the voice data being exchanged. The most common signaling protocol used in VoIP systems today is the Session Initiation Protocol, abbreviated as SIP. This protocol is responsible for establishing sessions between devices, whether those sessions involve voice, video, or other types of communication. SIP operates over either Transmission Control Protocol or User Datagram Protocol using port 5060. It is not used to carry voice traffic, but to set up the parameters that will allow the media stream to begin and end properly. When security is a concern, SIP can be encrypted using transport layer security. In this case, the secure version of the protocol is referred to as SIP-S, and it uses Transmission Control Protocol port 5061. This encrypted variant ensures that signaling traffic, such as call setup requests and authentication data, is not visible to attackers who might be monitoring the network. Because SIP-S uses digital certificates, the devices on both ends must trust each other's certificates for the session to be established. Using SIP-S is a best practice in any network where sensitive call signaling data is transmitted, especially over public or untrusted links. While SIP sets up the call, the actual voice data is carried using the Real-Time Transport Protocol, abbreviated as RTP. RTP is designed for transmitting audio and video over IP networks in real time. It uses dynamic user datagram protocol ports that are negotiated during the call setup phase. Because RTP traffic is time-sensitive, it does not attempt to retransmit lost packets. Instead, it prioritizes consistent timing and low delay over absolute reliability. This is important for maintaining natural-sounding conversations, as retransmitted audio would arrive too late to be useful. Understanding that RTP carries the voice while SIP manages the session is a frequent focus on the exam. Modern VoIP systems often connect to the public switched telephone network using SIP trunks. A SIP trunk is a virtual connection that replaces the need for traditional analog or digital phone lines. It allows VoIP systems to send and receive calls from regular phone numbers while maintaining all call control in the digital domain. SIP trunks are managed through SIP signaling and are typically hosted by a provider that routes calls between the VoIP network and the public telephone system. This approach reduces costs and increases flexibility, especially for organizations that place high volumes of long-distance or international calls. Before a VoIP phone can make or receive calls, it must register with a call control system. This process begins when the phone sends a SIP register message to the call manager or SIP proxy server. The server responds by authenticating the device and recording its IP address and location. This allows the call manager to route inbound calls to the correct device. Registration is not a one-time process. It must be renewed periodically to ensure the server knows the device is still reachable. This registration step is a key part of VoIP infrastructure and is often referenced in scenario-based exam questions. The call setup process in a VoIP system is a multi-step exchange between the calling and receiving devices. It begins when the caller sends a SIP invite message to the recipient. This message includes details about the media formats the caller supports, such as specific audio codecs. These details are exchanged using a protocol called Session Description Protocol, or SDP, which is embedded in the SIP message. The recipient responds with its own capabilities, and once a match is found, the two parties begin the RTP session to transmit voice data. The exam may present a question describing this sequence and ask which protocol manages call initiation, or which one carries the actual audio. Voice quality in VoIP networks is influenced by several factors, including jitter, latency, and packet loss. Jitter refers to variation in the arrival time of packets, which can cause gaps or choppiness in the audio. Latency is the delay between when a word is spoken and when it is heard on the other end. Packet loss occurs when voice packets are dropped before reaching the recipient. All of these problems are more likely to occur during periods of network congestion. To maintain voice quality, many networks implement quality of service policies, also called QoS, to prioritize voice packets over other types of traffic. Network address translation, or NAT, can introduce significant challenges for VoIP communication. Because SIP messages contain IP addresses and port numbers inside the payload, a basic NAT device may not know how to rewrite those fields correctly. This can cause one-way audio or complete call failure when trying to communicate across the internet. To overcome this, VoIP systems often use additional protocols, such as session traversal utilities, for NAT, abbreviated as STUN, or traversal using relays around NAT, known as TURN. In more advanced deployments, session border controllers, or SBCs, are used to manage and normalize signaling between internal and external VoIP networks. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Call management systems are the backbone of any functional VoIP deployment. These systems, which may take the form of on-premises private branch exchanges or cloud-hosted solutions, control the signaling between endpoints and determine how media streams are routed across the network. A call management system processes registration requests from VoIP phones, authenticates users, manages active call sessions, and enforces policies such as call forwarding, hold, voicemail access, and extension dialing. Without centralized call management, a VoIP system cannot scale efficiently or deliver features like call routing and directory services. On the exam, understanding the relationship between endpoints and their controlling systems is important for identifying where signaling problems may occur. In any VoIP environment, codecs play a vital role in determining how voice is digitized, compressed, and transmitted over IP networks. A codec, short for coder-decoder, compresses voice data to reduce the required bandwidth while preserving as much audio clarity as possible. Commonly used codecs include G.711, which offers high-quality audio with minimal compression, and G.729, which provides significant compression at the expense of audio fidelity. The codec used during a call is negotiated between endpoints during the SIP signaling process. The chosen codec impacts bandwidth usage, call quality, and system performance. Selecting the right codec is essential for matching voice clarity to available network capacity. Port access is a frequent source of issues in VoIP systems. SIP uses Transmission Control Protocol or User Diagram Protocol port 5060 for standard signaling and port 5061 when using SIPS with encryption. Real-Time Transport Protocol, which carries the voice data, uses Dynamic User Diagram Protocol ports negotiated at the start of each call. Because RTP uses dynamic ports, a wide range of high-numbered ports must be opened on any firewall between VoIP devices. If these ports are blocked, the call may connect but result in one-way audio or silence. The exam may present a case where calls connect but have no sound, and the correct answer will involve understanding how RTP ports interact with firewall rules. Securing a VoIP system involves protecting both signaling and media traffic. For signaling, transport layer security should be used with SIP to create encrypted sessions. This ensures that call setup information and credentials are not exposed. For media, Secure Real-Time Transport Protocol, abbreviated as SRTP, encrypts the voice data itself, preventing eavesdropping. Additionally, access to call management systems should be restricted to trusted IP addresses, and authentication policies should be enforced to prevent unauthorized devices from registering. Monitoring for call tampering, toll fraud, or unusual registration behavior is essential for maintaining the integrity of the system. Quality of service, or QoS, is another key concept when managing VoIP traffic. Because voice is highly sensitive to delay, jitter, and loss, it must be prioritized over less time-sensitive traffic, like file downloads or web browsing. QoS settings may assign voice packets a higher priority using differentiated services code point values, or by placing them in a separate virtual local area network with dedicated bandwidth. This ensures that even when the network is under load, voice calls remain clear and uninterrupted. Implementing QoS is especially important in shared infrastructure environments and is frequently referenced in certification questions related to network performance. VoIP troubleshooting requires a clear understanding of how signaling and media paths function. If a user reports that a call connects but only one side can hear, the issue may lie in how network address translation is handled or whether RTP ports are allowed through the firewall. If calls are failing to connect at all, the signaling path should be checked to ensure that SIP registration is completing successfully and that the correct port is accessible. Tools like packet capture or session trace can be used to verify that SIP invite and response messages are being exchanged properly and that SDP media negotiations are resulting in compatible codecs and ports. Although SIP is the dominant signaling protocol for modern VoIP systems, it is not the only one you may encounter. H.323 is an older but still used protocol that was designed for multimedia communication over packet networks. H.323 is more complex, with a tightly integrated set of specifications covering signaling, media transport, and session control. While robust, its complexity makes it harder to implement and troubleshoot. SIP, by contrast, uses a modular approach that separates signaling from media handling, making it easier to scale and adapt. For this reason, SIP has largely replaced H.323 in modern deployments. On the exam, you may be asked to compare these two protocols and identify which one is preferred for simplicity and scalability. When studying for the exam, pay attention to how SIP and RTP interact, which ports are used, and what kinds of issues arise when those ports are blocked. Understand how SIP registration and call negotiation work, and be ready to distinguish between signaling failures and media path issues. You may also encounter questions that involve quality of service, firewall rules, or codec selection. Each of these factors plays a role in delivering clear, secure, and reliable voice communication over IP networks. A firm grasp of how VoIP services function and how they are affected by network design and configuration is critical for success. In conclusion, Session Initiation Protocol handles the signaling that starts and manages VoIP calls, while Real-Time Transport Protocol carries the actual voice data. Together, they enable voice communication over IP networks by separating control and media functions. Supporting technologies such as codecs, call management platforms, and quality of service policies ensure that VoIP systems perform reliably and securely. For both certification success and practical network administration, knowing how SIP and RTP work, what ports they use, and how they interact with firewalls and network address translation is essential. And thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.